Math 2, what you're going to see today is a review of problems that were on your formative number 1. What I'm going to start with is a graph that matches number 1 on the formative. So if you needed help with number 1, please use this to help you fix what you need. When we look at the graph of an absolute value function, our x-intercepts have the same properties as any other x-intercept regardless of the shape of the graph. I'll mark the points here in pink. Watch your ordered pairs. We're at -3, 0. Remember that x-intercepts have a y value of 0. There were 2 in this case. Remember, x-intercepts you can have none, 1, or 2. We've also got an x-intercept at -1, 0. Similarly, the y-intercept has the same properties regardless of the shape of the graph. Watch your ordered pair again. The y-intercept has an x value of 0, and in this case the y value is at -3. Now, for any absolute value function, our domain will always be all real numbers. That's any absolute value function. That means any x value that I can think of, any number at all, positive, negative, large, small, decimal, fraction, whole number is a possibility for the domain. So all real numbers are my domain. Now, for the range, we're actually going from lowest point to highest point, and we want to split our range at that vertex point. So this vertex here is at -2, +3, -2, 3, oops, -2, 3, and since we're going lowest to highest, there is no lowest point. That graph goes down forever and ever and ever. So at the very bottom of our graph, we're actually going as far as we can down to -infinity. It's never going to stop at the bottom. But as we move up, that graph stops at a y value of +3. Be careful that you're looking at the y values for your range. Now, intervals of increasing and decreasing are going to behave a little bit differently because they are a left to right. So we're looking at the y value of, the x value of -2, and then we think about the idea that we split our graph into 2 sections, a left section and a right section. And as we move to the left, that graph heads to -infinity. As we head to the right, that graph heads to +infinity. When I read my graph from left to right, remember this time we're reading from left to right. With the range, we read up and down. For intervals of increasing and decreasing, and for domains, we read from left to right because we're looking at x values. We're increasing here. We go up to the vertex, and then we hit that point of inflection, and we decrease. So when I look for my interval of decrease, on the left-hand side, I have -infinity. And on the right-hand side is the -2. Don't forget your square bracket around the numbers. And then for my interval of decrease, we start at -2, again a square bracket around the number, and we end at +infinity. The plus there is just for note-taking purposes. You don't have to put the plus, but you can for positive infinities. Numbers 2 and 3 match, again, your formative numbers 2 and 3. We're going to talk about descriptions, okay? We want to describe in words the transformations performed on our graph, f of x, to get g of x equals to -2 f of x plus 3. Now remember, f of x is your absolute value function. So what we can do, if it helps you, is replace that f parentheses with absolute value bars. So that means that the f and the parentheses completely go away, and we replace it with whatever our function was, in this case absolute value bars. Okay? Now, the negative I will highlight with, let's start with orange, and then I'll write in orange. The negative tells me that I had a reflection over the x-axis. Okay, negative tells me I have a reflection over the x-axis, reflection over the x-axis. Please make sure that you specify that it's the x-axis. We can reflect over lots of places. X-axis is just one of them. Let's go green for the number 2 here, as that's a coefficient and we're multiplying. When I multiply by a number that's greater than 1, what we end up with is a vertical stretch. It pulls our function from top to bottom and narrows it out. So we have a vertical stretch. And then what I have is that plus 3 on the inside. Remember, anything on the inside attached to the x value is in x direction, but the x directions always take on the opposite sign. So instead of moving in a positive direction, it's a negative direction, which for the x values is a left direction. So we're going to shift left 3 units. And that's it. There's nothing else different about our function from the parent function, so those are our 3 transformations. For number 3, we're actually going to write the example. So given our basic function, our parent function, remember f of x equals absolute value of x, we're going to write an example of a transformed function g of x. So we're going to call it g of x. That's been translated down 5 units and vertically compressed. So let's leave some spaces. We can have a number in front, we can have a number on the inside, and we can have a number on the outside. The down 5 units is a vertical shift. Y values when we move up and down don't have to take on the opposite sign, so down just is a -5. It goes on the outside. And then that vertical compression is a number less than 1. So we can pick any number we want as long as it's not negative. There was no reflection over the x-axis. Any number that's less than 1, for instance, 2/3, 1/2, 3/4. Any number less than 1, let's go with that 2/3. You can pick any fraction you want, again, as long as it's less than 1, but not negative, because we had a vertical compression, not a reflection over the x-axis. And then we'll just rewrite this now without all the lines and the blank spaces. G of x equals 2/3 absolute value x minus 5.